Hello, thank you for being there. Finally, I will be introducing the exploitation panel in terms of program and flow. Program, it's lasting for 60 minutes, 90, sorry, 1.5 hours. So we will have time discussing. First, there will be a short introduction, then a presentation of our 4 panelists, and thank you for being there, either in real or online for Ortwin in Potsdam. I will start introducing a little bit the project for those who were not there this morning, especially for Ortwin. And then we will switch to the discussion. And in the end, we will have 30 minutes for really discussing, asking questions, and so on. As a remembering, sorry, the first introduction was, hello, my name is Marion Perrin. I'm a research director for Energy Pool, who's an industrial company, an aggregator with headquarters in France, but acting on the markets in Netherlands, Japan, and other countries such as Saudi Arabia. And we are delighted to be part of the FlexRICAN project, where we try to contribute our knowledge of the markets and the flexibility of consumers that can play a big role on the electricity markets in terms of stability of the grid, for example. And second, what we intend to get from the project is a better knowledge of these very special assets that are research infrastructures that could contribute. We already had some tests with LNCMI, and that's working quite fine. So they could help the grid in terms of flexibility. Therefore, FlexRICAN is a 36-month project funded by the EC in order to investigate flexibility for research infrastructures, for making them more sustainable. We have a quite great consortium with 3 large research infrastructures. We are 2 industrial partners, one that is more electricity focused and one that is more heat focused with Alfa Laval, a university. Several research facilities, and we cover 7 countries. The project started in March 2024. It covers both technical work in terms of energy integration in research infrastructures, electricity storage, renewable energy integration, flexibility, life cycle assessment, and building management systems. That's more the technical part of FlexRICAN. And we have a mission of reaching out of the consortium. And this is why this panel is so important to us, because the idea is that our results can be exploited outside of the project, outside of the countries of the project also, and that the rest of the RIs and the rest of the European community can gain from the knowledge we gather in the project. So for this exploitation panel, we have 4 panelists. To each, when you will start presenting or the discussion, I would love you to introduce yourself within 1 sentence, because one is never as well presented as by oneself. In the first line, Ortwin Renn will show or present us some ideas or some work he's been doing. So the objective of this panel discussion is really in the framework of the outreach activities and valorization of the activities of FlexRICAN. We want to enlarge the impact of the project. And to each of you, I will ask a similar question is, thank you for being here first. And what takeaway could you give to FlexRICAN? Because we still have 18 months to work in front of us, or even more, sorry. What would you give us as an advice for increasing the impact of the project and the exploitation? We can do that. In first line, would you contribute to example of actions that you undertake in your facility or in the frame of your work regarding sustainability of research infrastructures? And in first line, the testimony of Ortwin would start the discussion. Can you hear us?
Yeah, thank you very much. I'm very happy to be here. I'm certainly not a part of the FlexRICAN team. I'm an outsider, and I try to be very attentive to the context in which all of that happens. And hopefully, in the end, I can also answer your question about, what should be the focus of this research and what can we do. Can I have my first slide?
Yeah. Oh, sorry. This is the one.
This is the one, yeah. So this is just the topic. I would like to talk about sustainability, and let me just go back to you. I think that's something that you all know very well, but I think it's good to remind you of this. This is the second slide. So the next slide, please. What do we mean when we talk about sustainability? And I think it's very important. Sustainability is an orientation. It's something that's normative. It's needs analytic work, but it's basically a normative goal. And the goals are twice, or two parts of it. First one is to secure the environmental foundations and the humane living conditions for all of humankind. So it's a combination of making sure that the ecosystem still serves the needs of humans and of all other living beings, but at the same time, this should be done by maintaining humane living conditions. So we don't want to have dire living conditions, but still want to have a long-lasting life for humanity. And this should be done for the present and future generations worldwide. So we're talking about but also intergenerational equity. And we normally divide sustainability into three different columns. The first one is ecology. That's probably what you're mostly concerned about. So that's energy, material, and I get back to that. Secondly is economics. So we're talking about circular economy, for example, as a part of sustainability. And thirdly, it's also social and cultural aspects, because if you want to prepare and maintain humane living conditions, it's very important that we also have the institutional and social means that people can have these kind of humane living conditions. Next slide. Now we can see the major dimensions of these three different pillars. And you can see that in ecology, and I said that's basically what the focus is on this session, is we want to decarbonize the economy, not to zero, we all need carbon, but to reduce the carbon emission into specifically the atmosphere. We want to have less emissions and less material, because it's dematerialization. So being very efficient about what we use. We want to minimize waste, so emissions in terms of solid waste, but also in terms of liquids and in terms of gas, and want to try to recycle as much as possible. And lastly, we don't want to intervene too much in terms of land use management. We want to make sure that we have a lot of natural lands left, because that's part of the ecosystem services that we all need. So land use is another issue, and that's where we very often need to renaturalize cultivated land. In terms of the economy, it's the circular economies that I mentioned, and that, of course, is very much in line with dematerialization and waste minimization. But we still want lasting quality of life and work. I mean, that's what we're all about, and that's really what humankind needs. And of course, we also need to have a system that dynamically adapts to changing environmental conditions. So that's the kind of evolutionary path. We all are part of evolution, or we basically accelerate evolution in the German and the in the civilized and culture, but and nevertheless we are part also of the natural evolution, and we need to be sure that we can adapt to changing conditions. And lastly, we have the social and cultural dimension. So one that is always mentioned, it's really important, is social justice. It's not that we all have the resources available, but we also should be fairly distributed. We need peaceful means of conflict resolution, something that is, of course, very topical at this point in the world history. And lastly, kind of individual and social identity, cultural meaning, something that humans need. Now, I want to focus this more on the topic of this panel, and so we need the next slide. And there you see that we are talking about energy management in terms of life cycle analysis. And that's, the basic element of the whole project that you're dealing with. And again, I want to just show you what is the varieties, the scope of things that we can think about. And firstly, of course, the first thing that comes to my mind is efficiency improvement. So efficiency always means that we can use one item of natural resources, and we get more services out of it than we have done before. So out of 1 kilogram of coal or 1 liter of oil, we want to have more services than we had before. And so the measurement there is a ratio between primary energy and energy service. And we can make sure that that ratio is getting more and more efficient, so that we get more energy service out of each unit of primary energy. And the second part of this is energy cascading in terms of heat recovery. Now we can see that the waste of one industrial process becomes an input to another, or that, for example, heat that we normally generate when we generate electricity can be used maybe for other purposes. The second energy management thing is a choice of primary energy. So in addition to efficiency, we sometimes also call this consistency, is we need a primary energy source that emits low carbon emissions. Or no. I mean, if we have renewables, basically it's zero emissions. With others, it's less or more, and that we rely on renewable energy sources, but also just reducing carbon emissions from, for example, normal fuel would also already be a progress. And thirdly, again, when we come back to our main elements, it's material waste and land use, and that is basically the quality and also the quantity of waste that we produce, and it's input and output. So we have resources. I mean, if you have batteries, we know we need a lot of minerals and other kind of metals in terms of having these batteries. Again, we can minimize that, or we can at least try to recycle it. And it's the same thing, of course, is also that other resources that we might want to use in terms of energy production or energy transportation can be, of course, be reduced in amount necessary. Minimization of waste and emissions, I talked about this already, something that very important, not only for carbon emissions, but also for other pollutants and also for solid waste. And again, batteries may be a good point. And limitation of land use and land use impacts. We know if we have conflicting values here, if you rely very much on renewable energy, we probably need a lot of land. Normally we do, so wind and solar needs much more power than, for example, nuclear energy. Needs much more land, sorry, needs much more space than, for example, nuclear energy or coal energy, is because of the density of energy production. So again, we need to make trade-offs here. And of course, we can make win-win situations by having a renewable energy on top of buildings, or have it where we have other types of use. We have dual-use agriculture at this point that are we're able to use land for agricultural purposes, but at the same time harvest solar energy. Next slide, please. Yeah, well, that's already the end of my presentation. What I wanted to point to you is that we have a more systematic view on how to reduce energy and specifically how to improve our climate performance, climate protection performance. And it's good to be systematic about it. And I think all this kind of a total analysis over the whole value chain is very important. So life cycle analysis, I mentioned that before, and I would say, where do we get our input? What is the transportation means? What is emissions? What is the waste? And what comes out in terms of, in the end, in terms of environmental impacts, but also land use, is something that we need all to get into a spreadsheet, and now to find out, how can we minimize it, but at the same time sure that we have the right trade-offs, that we are not reducing something very minimally by aggregating something else that is much more detrimental. Okay, that's all what I would like to say at this point, and I'm looking forward to the other panelists. Thank you very much.
Thank you, Ortwin. Thanks a lot for this contribution about the KPIs of sustainability that we should and could apply to the areas. We understand it's going much farther than only the kilowatt hours in terms of energy. Now we'll hand over to Christian, that you may give us a testimony of actions that are undertaken at ESRF. And please, can you introduce yourself shortly in beginning?
Okay, sure. Can we hear me well? Okay, thank you, Marion, for the introduction. So, good afternoon to all, and that's a pleasure for me to be part of this panel today. So I'm Christian Nevo. I'm in charge of the technical infrastructure division at the ESRF, which is located nearby. And I will make a presentation now related to the activity at the ESRF related to let's say general efficiency savings, as Marion required. Yes. So just as a first introduction, what is the power consumption profile at the ESRF? You can see on the plot on the right-hand side of the slide that we have different periods in the year. So we have some in the rectangular zones, the shutdowns that let's say that is our way of organization, and then you can see that the power consumption is quite stable along the year, and in the end quite predictable. So we can at the beginning of the year predict and define what would be the power consumption that we will have for a year, which is quite a critical point for the supplier, energy suppliers. And the point is also that in our business model we have to let's say give the light to 40 beam lines in total. So it means that at the same time we have 40 beam lines in operation, which shows that in case of failure of the machine of our overall system, the impact is quite important, and that's why we were to have the best availability possible for the machine, which in 2024 was close to 98%, which is reasonable, good results. So we have 200 days of user service mode, split in 5 runs, as you can see on the graph, and we attract something like 9,000 users a year. So it means that there is some kind of impact on the availability of the machine, and this is related to the flexibility topic that we have, in fact, some constraint on this matter. So in the past years, we mainly at the ESRF concentrated on the energy efficiency topic, and knowing that it was mainly the orientation, given that our carbon footprint assessment was related to scope 1 and 2, so it's encourages us to work on this mainly on this part. This is also a kind of a natural way of doing. I mean, starting to do to work on the efficiency of the installation before going further, and the next step would be to investigate a little more on carbon footprint reduction on this side, which is also accompanied by the regulations with the scope 3 that we have now to detail in our greenhouse gas survey. So what we have noticed from 2010 to 2024, we made some savings. You see on the plot on the right-hand side, the blue dots correspond to the total power absorbed by the facility. So it includes electricity and heat. The electricity is the heat correspond to nearly 10% of the total electrical power consumption. And the result is as shown there. You see that we have a drop in 2010 and another one in 2018 that corresponds to major overhaul that we done at the ESRF. So the machine was basically stopped during this time. So that's the reason of the drops, not energy efficiency or not energy savings. But then from 2018 to 2021, the red arrow illustrates the saving made with the new machines that has been put in place, the EBS, and we'll see a little more after. So which in fact provided the major saving in all time for the ESRF. But further, we have a second option, and we see after that we called Eco Mode that provided 1.6 gigawatt hours of savings. And then a series of other actions that we have implemented from 2010, starting from various actions like lamp replacing, but mainly improvement or in the process, the cooling systems, the chillers of the plant that has been improved along the time, and that provided altogether consolidated this 12 gigawatt hours of energy saving. On the top of that, which is not reflected, I think that we had something like 5 gigawatt hours additional consumption that is coming from the additional surfaces. The ESRF is a living site. We are always implementing new labs or new facilities or new places for the beam lines. So that's what we done with the Chartreuse Beldon, which are two new experimental halls. The log, which is a laboratory and office building, and ESRF 1, which is it's a workshop for the insertion device. So that's the full picture of what has been done in the past. Effectively, now in the coming years, we will more concentrate on actions that are related to more carbon saving. What we see is that we are going to, in terms of energy efficiency, we are going to a kind of asymptote. So now the more we go, the more expensive will be the efforts to be put to save every kilowatt. And in addition to that, the ESRF, and it's not in the numbers, but ESRF is committed to welcome some experiments that are related to energy saving or to carbon footprint reduction in all means. So I think that we have something like 30% of the research done that is related to these various topics. So going to next slide. So a few words about this drop. So the red arrow shown in the slide before. So it's together with the implementation of what we have called the extremely brilliant source, which is the new accelerator, the new storage ring complex. As you can see on the graph in the middle, let's say the general design of the machine is quite the same. And we still have a 6 GeV machine with the same basically dimensions, but with a different design, which provide main benefit a much smaller beam, which is illustrated on the bottom of the slide. But that has been used to include into the design some features that provide energy saving compared to the previous machine. And mainly, the two main solutions done with the machine was to implement permanent magnets on one side, and the other side to improve the optimization between magnets and power supply. With these two guidelines, we get this 12 gigawatt hours improvement on the machine, which is substantial. And then, when the machine was put into operation, we started with some parameters of operations that were close to the ones we have with previous machines. We identified some source of improvement there due to the new characteristics, new features for the machine. And one of the main one was this eco mode, which consists in optimizing the voltage of the radio frequency system, one side. And the second side is to optimize the number of generators that we use as backup power. That's our flywheel machines that we use to secure the electrical network and avoid having some voltage drop on our internal network compared to the grid. So it was mainly by reducing the number of machines in order to fit with the new power consumptions of the overall system. Next, yes. Okay, so this is an example of what has been also done in the recent years at the ESRF. So I think that most of you will visit the heating pump project just after this talk. So this one will be presented more in detail by Pascal Robuisson, who is the engineer in charge of developing this machine. What is interesting to note is that yes, we have a project cost of close to 800 kilo euros. We evaluate the payback period at less than 4 years. On the top of that, deduct from the project cost, we also have subsidies from ABB. And we also have some certificate of energy saving that we can also benefit from the savings made thanks to the solution. So the real cost for ESRF is largely less than the 800 euros in the end. The system has been put into operation starting from July last year, 2024. So we already have experienced one full winter period. So we have already some good ideas on the results that we can have on the energy we can save with this installation. One point to mention also is that on the flexibility side, which is a bit different of interpretation that you mentioned before, we have this capacity to have a backup from the district heating, so they can provide 100% of the power we need, which means that in case of failure of the heating pump, we can we have a secure source of energy from the district heating. And this option can also be used in case of the electricity price start to rise as we faced in the past years. Next slide. And so finally, so this is the coming project. So the next step that we plan to implement is like some of our neighbors there on the presqu'île to install some solar panels. So after some studies, we have selected to cover the main parking lots that we have at the ESRF. So it's shown on the drawing top right. So today, what we anticipate is to cover 3% of ESRF needs. So it's a starting point. And the construction, we expect to start the construction by next year for 2 years of activities. And one of the key benefit of these solar panels will be to help us to comply with the Décret tertiaire, which is a regulation in France that is a bit drastic on the tertiary buildings that impose a reduction of 40% of our energy consumption for 2030. And with the solar panels, I think that we will be close or in line with the requirements. In terms of carbon footprint, I mentioned that the impact for us here in France is a bit limited. I put there an extract of what was a situation in one day in March. So quite recently, as the carbon footprint on the French network, and you see that when the solar panels are producing, so from 10 to 6 in the afternoon, the carbon footprint within the French network is very good. And that's it for my presentation. Thank you for your attention.
Thanks a lot, Christian. One question: what is the power of the infrastructure? So the energy is
So the
yeah.
total absorbed power
Yeah.
a year is 50 gigawatt hours.
Yeah, but the power.
The power is we are oscillating a maximum at 7 megawatt.
Okay.
And can be down to 2 megawatts when we are in Chile.
Thanks a lot. Impressive. We will visit that afterwards. Great, thanks a lot. Hanna, would you give us some glimpse on the LCA of a research infrastructure, and in particular something we did not say in the beginning, the share of energy in it, but that's not only energy.
Yes, of course. Hello, everyone. Thank you. So yeah, first of all, thank you for inviting me to this panel and to this event. It's been really interesting to talk to a few of you. So my name is Hanna Wakeling. I am a postdoc at the University of Oxford at the John Adams Institute for Accelerator Science. I'm also working on the IASS neutron and muon source, which is in the UK, just south of Oxford. And sorry, am I interfering? Is that better?
Yeah.
I'm sorry. Okay. Did you hear everything? So okay. So I'm also working on IASS, and I'm a part of the HECAP Plus initiative. And that's pretty much my introduction. So I can go on to my slides now. So as part of my work, I'm working on a life cycle assessment of the upgrade to IASS in the UK. That it would be an example of a research infrastructure. And so I'm working on the LCA of a conceptual design of all the options that we have at the IASS 2 neutron muon source. And it's currently identified as a potential UKRI multi-stage mega project. As I said, south of the UK, just by the Rutherford Aperture Laboratory. If you're aware of it, most of you likely are. It's proposed at the moment to be probably a 2.4 megawatt beam, but this is still under design consideration. And in theory would be open to users from around 2040. And within my modeling, I've been using around 60 years of operation in comparison to the current IASS experiment. But the LCA is very much ongoing. Unfortunately, I can't share the results with you yet. So everything I'm going to show to you today is very much preliminary findings with huge caveats. But as a snapshot insight, I can share this diagram, which is basically showing that depending on your grid regime, depending on the way that your country or the countries that you take your power from to generate their electricity, you can have up to, or sometimes more than 65% of your operation being your lifetime full carbon impact. This, again, a huge caveat that this does not follow the predicted the goals for us to reach net zero in the next decades. So hopefully it's going to be a much nicer outlook than that. In a net zero world, the operations from power would naturally be zero in terms of carbon impacts, depending on how you count those as well. Naturally, renewables do not have an actual net zero, and they do need to be offset in other ways. But also looking at good scenarios, the number could be more like equal to the construction impacts, so more like there would be one-to-one comparison with the embodied impacts. So this is looking more as a worst-case scenario, is as a business as usual generation of our electricity scenarios. Next slide. But with an LCA, what we can do is we can then look into the way that we are using that electricity. And so again, a hotspot analysis of the way IASS 2 would consume power. You can see straight away that our impacts come from our accelerator, so the linear accelerator and the synchrotron. That's one design we're looking at, and the cryogenics. So these are the main power consumptions that we're looking at. And so this is where we could really benefit from something like FlexRICAN, where we can look into being more flexible, optimizing our LINAC designs, our ring design, looking at our cryogenics, our working temperatures, looking at either storing or recovering our waste heat, and looking at producing local energy, renewable or otherwise, and others, obviously many more options there. So what really is the way forward, especially using LCAs? There's so many paths that we could take, and hopefully LCAs can help us identify those alongside the way that we FlexRICAN are taking each of their working projects packages. But specifically for energy consumption within our operations, there's the four main points that we need to focus on, which is preventing, reducing, reusing and recycling, and also collaborating. So as I've shown on the slide, within preventing, we can optimize early without design decisions. So using LCAs, we can understand where our impacts are and then design into an unbuilt accelerator facility or research institute the ability to prevent the consumption of electricity. We can perform and utilize LCAs to do that. And we can also strategize on energy efficiency. We can look into new technologies, whether they'd actually truly be better, for example, comparing normal conducting LINACs to superconducting LINACs or other like magnets, etc. And also integrating renewables from the offset. Within reducing, we want to think about developing our energy flexibility. Do we need to be running full time all the time? Are there ways that each different research infrastructure can optimize in different ways? Again, what FlexRICAN is focusing on. Can we reduce our peak energy demand? And when that occurs, can we optimize our operations in other ways? And then finally, with reusing and recycling, as we've discussed, recovering our waste heat, storing our waste heat, and trying to reuse that in a circular manner. It is really important. And finally, collaboration. I think we're going to discuss that a bit more, so we don't have to focus on that. So I'll shamelessly plug the fact that I'm organising a Sustainable High Energy Physics conference, and we welcome anyone who's interested in that area to come and join and find out more if you want to.
Yeah, thank you for sharing the opportunity. Yeah, that's and I suppose these LCAs in advance were not performed in the last eras that were built. So perhaps that's a topic for later in the discussion, comparing between. So thanks a lot. Max, would you give us some testimony on how far research infrastructures can impact the industrial world and reciprocity in these relationships?
Yes, thank you, Marion. And also I'd like to say thanks to the FlexRICAN team for involving me in this panel. It's been really interesting to talk to you about the work that you're doing and to be here as part of this initiative. Now, in view of or also I should introduce myself.
Yeah, you should. Please.
Again, I am Max Collins. I am Swedish Industrial Liaison Officer. And when we talk about industry engagement and we talk about valorization and knowledge transfer, that's exactly the purpose of an industrial liaison office. And the way that works in practice is that we have built and continue to build a network of companies and research groups that have relevant expertise and the competence and also interest in the big science market and big science technology. They're also active in other markets, but in our view, with respect to big science technology. And then on the other hand, or at the same time, we as industrial liaison officers, we spend time at our respective big science or large-scale research infrastructures to talk with management, technical personnel, procurement officers, and grant officers to try to understand what are the needs, what are the challenges, what's coming up ahead, and where are we going with this, and try to translate that into technical requirements that sort of can match the competences of the network that we're having. And if there is a match, of course, we try to promote and facilitate that contact in making sure that if there is a procurement opportunity or an opportunity to collaborate or for knowledge transfer, that they're involved in that. And I wanted to share a video of practically speaking of what this can look like. And this is a knowledge transfer project between, so don't start it just yet. This is a knowledge transfer project between Swedish company ABB and large-scale research infrastructure CERN. And they are partnering up to look at energy efficiency improvements in electrical machines in the CERN cooling and ventilation system. And the results that they're having is really quite astounding. And I choose this example because it illustrates also how we work, because this is a project that, or an opportunity that we found as part of a CERN Discovery Day. And we thought that this is precisely the know-how of ABB. So we reached out to ABB and we put them together and promoted and facilitated this project. And now they're having these results. So I think these results are really quite astounding. And what I really like about this project is that you have sort of a bidirectional knowledge transfer. I mean, of course, in the beginning, ABB, they're developing a new technique. They partner up with CERN and jointly they try out this technique using the CERN facility as a unique test bed or a unique testing resource. And you have now almost 20% reduction in this facility across the board. That's, of course, a great result in itself. So it's a win-win situation for ABB and CERN, but then crucially, there's also a third win when you're able to take the data and the insights and the knowledge and now transfer it into society or to apply it to the markets and industry that ABB is already accessing. And then you move from, as they say here, 800 machines to millions or hundreds of millions of machines. And that's really, of course, an astounding result. So I thought it was interesting to share this in this context. And of course, I'm thinking about how can we have the same type of results, or how can we have the same type of approach with the techniques that we're developing here as part of the FlexRICAN initiative. Thank you.
Thanks a lot. That's impressive. So thank you for these different contributions. Maybe going further in how FlexRICAN can reach a broader audience or disseminate its result. Would you have recommendations or hints about how to gain more impact? And the question flows in first line towards Ortwin, and then each of you will have the same question to answer, and we will collect with high attention all these recommendations. Ortwin?
Yeah, I'm happy to start. Thank you very much for the question. I think there are always two elements that we need to take into account. The first one, of course, is the technological opportunities that are there. And we need to monitor these technical opportunities. And we have seen it with the other panelists, what you can do in order to increase efficiency, to improve the amount of renewable energy that you can put into the system, and to make sure that your whole life cycle is being optimized towards less resource use and less emissions. The second point, I think, which is very important, and I think that has also been highlighted today, is the issue of cooperation among different actors. And we can see that very often that you have a group that is responsible, for example, for recovery of heat. The other group is responsible for buying items and materials. The third group is responsible for waste management and so on. And very often they optimize each of their tasks on the expense of the others. And that, I think, is a major lesson that we can learn. If you optimize, just one thing, you basically make things worse. And if you look at the whole system, then you have to make trade-offs and you have to find out what is the best thing for the entire life cycle. And then it sometimes makes sense maybe to have some little more, let's say, even fossil fuel involved than you would otherwise do. But you may save resources, you may save land, you may save waste or something else. So in that sense, I think it's very important to look at the entire life cycle and then to see, all interventions that are possible to look through the impacts on each of the dimensions that I had mentioned in my previous, in my first presentation. And so the two things, the technical improvements and to monitor those and our technical opportunities and the cooperation between different actors are, I think, the two key elements for a good performance in terms of energy efficiency and climate protection. Thank you.
Thanks a lot, Ortwin. A similar question to Christian. How could we reach a broader audience? How do you see it?
Yeah, I believe that already event as today is a good opportunity to share ideas and to share experience in order to get some in fact to identify the possibilities that we can implement in our own facilities. One of the points is we identified when discussing with other facilities that we do not have necessarily the same profile of power consumption. So it should be interesting also to have the capacity to define in which category we all land. And I think that with your energy pool, you probably have some capacity to provide guidance in this identification of the different facilities. And then for sure, what is very important is the force of the examples. And I think that it should be interesting if you can collect these examples with numbers to have for the ones that have to decide what could be some cost estimate, very basic cost estimates on savings that we can effectively do by comparison of what has been done.
You take over right now?
Sure. Take over straight away.
On the same question.
Yeah, so I mean, I concur with all that's been said so far. I don't know how much more I could add to that, but I did think about more like coming at it from a very different perspective or angle, looking at collaborating more with cultural and public institutions. So coming at it from a very outreach ground up perspective, taking it to museums, taking it to the local universities as public talks that the students can use as projects for their studies, to really gain that encourage the interest from an early age too, which helps in the future. And then the other idea was also just being very, very like having targets for your impactful audiences, like aiming at specific publications, and don't just stay within the field. Do not the word, but in collaboration within different fields. So really focus on sustainability and take that outside, because it really would be useful outside of the circles that this is already aimed at.
Yeah, thanks a lot. I try not to mix up the different lines. It's always the problem of the grader.
Yeah, so I agree as well with what has been said, and based on the video that I showed, I also would like to highlight industry engagement. I mean, there are overlaps in the techniques that you're developing here in FlexRICAN, as well as the needs of the industry, and you can find those overlaps. And if you can engage them in the ideas that you're developing, then you can have this type of knowledge transfer, and then there is an automatic boost in the dissemination and in the gain of impact, I would say.
Thank you, Max. Perhaps during the introduction, I missed one point that was dealing with. Sorry, I tried to share my screen, but it's all in French. But nevertheless, thank you, Anna. That's the right one. No, it's okay. I shared the right one. In order to open the discussion, perhaps, because we have your nice recommendation, FlexRICAN is aiming at We are almost there. Trying to have big. Yes. Oh. Yeah. There are different levels of what we see is that energy is making out a large share of the life cycle assessment, and especially energy during the exploitation phase. And thank you, Hanna, for showing that on your specific case. But I think this is also what we see on the other infrastructures. And when dealing with energy in research infrastructure or elsewhere, there are three ways we can improve the sustainability of the infrastructure in terms of energy. The first one, and we speak quite a lot about it, it's energy efficiency. So consume less energy. And he showed us there are huge levels that can be activated either by adding the right heat pump or the right drive to the motors, and that's one way. The second one is when consume the same amount of energy, choose which energy to consume, and that's a better energy or a low CO2 energy. And in order to maximize the use of low CO2 energy, that's where we start speaking about energy flexibility. But not only, because energy flexibility is allowing to have a better quality of energy, decrease the footprint of the consumed energy, but it's also lowering the need of additional infrastructure or additional grids and so on by helping the grid infrastructure in being flexible. So that's also something we need to have in the calculation. And therefore, as a small opening question or remark, there's a place where one could ask oneself, what is the competition between energy efficiency and energy flexibility? Because in order to make yourself flexible, it may be a bit more costly. You need to have power electronics that is multi-level, and that may need not IGBT, or IGBTs are not turret stores, or I don't know, I'm really bad in power electronics, which should be better. So how do you see this issue about how far we can go for energy efficiency, and how much should be put in energy flexibility, and do you see a competition there? And my first question will go to you, Max, perhaps.
Yeah. I think all aspects are important, but I think it's really true that the use of energy is something that is not very well utilized so far, and that's something where we can find a lot of potential quickly. Energy efficiency, improving the efficiency of converters or electrical machines, it's possible to do that, but it's a more, so to speak, a differential gain, whereas if you think you use it a little bit differently, you charge during one part and you discharge during another. That's much more potential, in my opinion, in view of these goals here.
Thank you. Perhaps we start having a more lively discussion from the audience. Are there first remarks or questions to our different panelists? Yeah, Sasha. When speaking, can you just speak loud, and I will reword the question so that at least I prove I have understood it also.
Yeah, thanks to all of you for your contributions. Very interesting, very impressive the energy efficiency results. So concerned, everything was very interesting. My question was about, when aiming for consuming less energy, we talked a lot about the energy efficiency improvements. The issue that can exist with energy efficiency is the rebound effect. That is to say, the energy efficiency is in relative terms. You have 50% improvement in energy efficiency, but at the end of the day, with a constant budget, you have 50% of energy efficiency, then you consume twice as much, or you do twice as much experiment, and at the end of the day, you have the same energy consumption, and so the same environmental impact. And so my question, it's a complex and intricate question, is how do we think about that? The IPCC is recommending energy sufficiency, that is to say, how do we have collective decisions on the actual needs we have, and so yeah, associated energy consumption we have. But that's complex in research infrastructure. So if you have some views about this, I'm all ears, because it's a complex question.
If I do rephrase what I understood is, how can we avoid by having our energy need to do a certain task, not to do twice the task for the same energy. So it's how not to increase our need of the service we had for a given energy, because just we are saving the energy and the budget that is associated. Would that be a question for you, Ortwin? Or did you hear the question from Sasha?
Well, I heard you rephrasing it, and certainly I think it's an interesting point that you also raise the issue of timing of energy service. I mean, very often we find out that you do a very efficient system, and then it is on the expense of reliability. And I think that's really an issue that we need to address, because you need to have reliable energy for your experiments, and because otherwise it can be extremely costly if energy is not there when you actually need it. So in that sense, I think it's very important to have this issue of sacrificing some of the efficiency to have high reliability. So you need to have some diversity, some redundancy, and so on as a system. But at the same time, if I understood the question right, is that if you overdo it, in the end, you may need, for example, more batteries or others to be flexible, and that can then increase the environmental footprint. Another thing is something that I try to point out in the beginning. Sometimes we have energy efficiency increase by increasing material or other kinds of environmental burdens. And that, of course, is you need to make good trade-offs there. And where again, I have to point out that cooperation between the people who do material analysis and who do waste analysis and do energy analysis work together, because you should not do one at the expense of others. I'm not quite sure if that addresses the issue itself, but I can see that efficiency is not an ultimate goal. It also has to be traded off against other goals, and flexibility and reliability is certainly one that we need to address.
Thank you. Any other?
Maybe I can comment. It depends on the way you manage all this. Point of view can be a little bit different. I mean that, in fact, we are facilities that we are committed to provide the best science as possible, and so it means that today we are all working with a given budget. Okay, so the budget is given for you for 1 year. And what you do with your colleagues is to try to do the best with what you have. Okay, so it means that also you have to do some choice. Possibly that today you need one lab that you will be very happy to have, one more facility, whatever. Possibly also some more computing power, because you need more. We are all in the same situation. So in fact, in the end, what happened is when we save money on the energy side, it's to use then after for something else. And so it's to develop, to benefit from this money that we can save, to do what we should have done before eventually, or to do what we have to do to serve the suppliers, to serve our customers. So yes, in the end, it's kind of a nul game, but that's the way we are organized.
Perhaps I can follow on from that. So, yeah, I agree. I think there's, like you say, it's a very difficult question, and you have to be very careful with how you phrase it and how you answer that. Proposing the idea of sufficiency and saying, well, you've got the result you wanted, we should stop there for the environment's sake. Very controversial way to answer it. But what I can say from the Research Institute's point of view is that, as you say, we're here for innovation, experimentation, evolution of science. And so from that, we can expect that our outputs kind of transform industry in theory. And we'd hope that that's the case. So the things that we find that improve the efficiency and reduce impacts in one way, if we do, as you say, use double the impact, we can still potentially see that the technologies get spread out to the rest of society. So there's many facets to it, but that's one positive to it.
And maybe just a hint of positive. If you save budget on energy, don't you put it on people? And that's a good way to think finally energy efficiency, especially in research infrastructure, is allowing to have more budget for having people doing good science. So I only see it positively, but the rebound effect is a good question, because sometimes it's more. I have put my solar panels on my roof. Now I can buy a swimming pool, and in that issue that's more personal and it's different. But for research infrastructure, I'm quite optimistic. Additional remarks, questions, or?
Yes.
Yeah, François.
I don't know if it's a general feeling. So concerning the question of trade-off, so when we see this presentation of CERN, so we can say it's scandalous that they can make 64% of energy saving, because it means that something was wrong during the conception. So we can see that this way. So this is why I think that now we are changing the way of seeing the things. Now we are, as you have explained, we are doing life cycle assessment of new facilities. So it means that there's been less job for ABB, but perhaps more job for other kind of studies and so on. I just put an example. So for example, here we are doing a high-magnetic field. So we want to produce a highest field. We produce waste heat in enormous quantity. But nobody wants our waste heat because it's too low temperature. The economicals is not so strong, and so on and so on. Just imagine we have to make a new lab. So we know how to make magnets that produce water at the right temperature for the network. But there are new players. I mean, so do we construct a new infrastructure research, including at the whole beginning, the district heating network? This is a heavy question. I mean, we know how to make the two magnets with almost the same performance, but it's changed the governance of the structure at the world. So this is open question. How can you answer to this? So for new infrastructure, I would say perhaps you.
Yeah, I can start. I think I guess where I'd go with that is, for me, the definition of sustainability. It means like circularity. And by definition, the way we use resources, we're not circular. We're trying to be, and we're getting better at it, but we're not. So personally, from my point of view, from a life cycle assessment point of view, incorporating that sort of thing into the design, I think is we have to do it, and I don't see why we shouldn't, other than purely financial and potentially time-consuming options that would. But realistically, can we morally not do these things? I mean, that's a question for everyone to answer if you want to, but yeah, perhaps someone else wants to jump in. I don't know if you want to.
Yes, on the same idea. I think that what you are doing on your facilities is really interesting, and I think that's the good way to do. I'm quite impressed by what you have achieved up to that. But for sure, to design at the very first step of the definition of the machine, design this energy saving option is quite critical. What we see, for example, at the ESRF is that today we produced something like, it was on the slide, but it was 36 gigawatt hours of heat that is normally wasted into the Drac River every year. And the problem is we do not have even the needs for this kind of power. So if you do not consider your facility globally in the environment, so with the city all around, then you miss something. But this can only be done at the very beginning when you start designing the plan. But effectively, there is some large room of improvement, at least if I speak of for the ESRF situation. Know that for LNCMI it's a bit different, but for the ESRF we have a large resource that we cannot tap because we are not at the right place to do it, and meaning that we have this one, but plus, for example, the heat coming from our data centers, we are not in position to recuperate this heat. Because the design of the data center and the buildings is not suitable for adding what is necessary for, or with a very large cost. So taking it so early, that's the way we are doing.
Thank you. Sorry.
No, I just want to, I don't feel the need to necessarily defend this video, but just to say that it was one machine that was 64%, not all of them. But then also, I totally agree with the topic of having a global view or a global optimization. I think that's really interesting, and I think that comes back also to the question before on sort of optimizing or improving the efficiency of components or individual systems, because when you have a smaller view, when you optimize a power converter on its own or an electrical machine on its own, the risk is that now you put constraints on the other systems and that everything as a whole has a lower efficiency or lower sustainability in this sense. So that's also another point to take into consideration.
Yeah, thanks a lot. Perhaps again for you, Max, there was a question during our discussion. Which barriers do you see in the transfer of knowledge that could arise between industry and research infrastructures and back? What is your day-to-day life in overcoming such type of barriers?
Yeah, I think this is also very interesting, and especially if we believe that engaging industry can have these type of results, and we would like to do that. Of course, makes sense to think about how to not fall into this. And I think in industry engagement, it's important to not do that at too late of a stage. And this is something that I see now working with fusion energy, for example. It's quite common that when they sometimes ask for, we would like this to be built. The system has been with margins on top of margins on top of margins, and the system is completely over-designed or over-engineered, and it becomes something that is too impractical to build or too difficult to build, or may even be that it's possible to build it, but I mean the companies, they have other things that they're interested in doing, and so it's not really competitive, and they simply say that we're not interested in doing this. So if you engage industry early and they really get involved and they see a benefit also in view of developing technology and so on, then I think you have better chances of having these results and engaging industry.
Small remark. There are two online guests, Rolf and Max, if they would like to ask some questions.
Oh, okay. So that may be is it in the chat or?
Yeah, no, they are already online. If they would like to ask questions, they can press the.
Okay. Mamad, oh, nice to see you. And Rolf are also there. Do you have any remark or question to our panelists? Or
no, I just joined the discussion. It's a very interesting discussion. Apologies for not being there in person. Serkan might have told you we are having the beam through our superconducting LINAC as of yesterday, which was too exciting to leave, even though FlexRICAN is very exciting also to be part of. But apologies for not being there in person.
We do understand, and we already discussed the fact of having a bottle of champagne here to spark it. So congratulations on that.
Marion?
Yeah, Diego?
Yes, I have a question I think links a little bit to what you just said about engagement of the industry and also the LCA. It's about how much do you think it's worth doing this retroactively? Because sometimes it's already too late. Yes, when you're designing the facility, it's great to have it. When you're doing an upgrade, these things come up. But sometimes, you know, the place is done, it's operating already. And doing this kind of studies takes time, resources, people. So most of the times, either they're not willing to do it or they think it's not worth doing it. And then the impact is you don't have either the data to find out where you can optimize this 60% of the machine. You don't find that, or you don't become someone interesting to the private industry. They look at you as a customer and they'll try to get some benefit out of it. And they go like, we collaborate, we might not get something useful, or we'll get bad reputation, but bad publicity because our result won't be great. So I guess the question is, do you think it's worth doing it, even if it's retroactively? And if so, how can we make this process a little bit more beneficial or optimal in that case?
Question is from me regarding industry engagement. I mean, I agree with a lot of what you say. I think these risks that you mentioned is precisely what I was getting into, so I agree with that. I mean, retroactively, just generally, maybe a bit of a difficulty, but of course, when you have this type of projects such as FlexRICAN, now you're developing actually new technology within. I mean, ESS is still under construction, but still, there are other facilities too. And then I think that there are a lot of overlaps, which could be worth investigating.
I think it's important to evaluate in a case-by-case situation, because there's a lot of technology that's going to be hanging around for decades. So I think maybe using something like an LCA or an environmental impact assessment to understand whether your efforts will actually be worthwhile is probably a good thing to do first. I totally understand, like it can be really hard or just impossible to make a big difference or make it worthwhile to actually reduce your impact, your environmental impact retroactively. But you know, like I said, some of these facilities that are going to be around consuming same amount of electricity for and maybe more for the next decades, I think we should really look into that.
And perhaps it also has one additional impact, is that you ask yourself the question at least, because it's possible to change things, and technologies are evolving quite quickly. So at least having a re-questioning of the design is healthy, especially for researcher, I suppose. It's exciting also. Yeah, Frans?
Yes, I have a question, maybe tying in a bit to what François was mentioning earlier. You presented energy efficiency as something where the focus kind of went to making a power converter or a device using its efficiency more, using its energy more efficient. But reusing energy is also a form of energy efficiency, I think. And in that sense, it's kind of sad to hear that there are places where we are consuming a lot of energy, creating warm water, which then for some reason people say, this is not interesting. And we will build an entirely new system to burn something to make a higher temperature water. So then essentially, if you zoom out to a larger scale, we are using the same amount of energy now twice for different purposes, where we could have used maybe at the expense of some energy extra, energy that was already used and transformed into a form of heat, and reuse it again. And I'm struggling a bit with formulating a question. I think it ties somewhat in maybe to the question that Serkan asked yesterday, as an outcome of FlexRICAN, what kind of policy note can we give? So can you comment or help us think about how can we influence people to start thinking about energy efficiency in this way, and to not say, well, this should be financially efficient, but rather because sometimes it's not financially not so efficient, but it is more energy efficient, meaning that on the global scale, we will reduce the amount of energy that we consume. And this is, I'm sometimes a bit of an idealist and optimist, thinking money is a pain in the neck when it comes to stuff like this. But I'm struggling with how can you influence people to start thinking about this concept in a different way. So I hope that makes any sense and is a bit clear for the panel.
So, Ortwin, I'm not sure you did hear the whole comment that was more about having heard that there is a lot of heat that is produced and that is not used, that is thrown away and not reused, and then that finally one buys a new machine that is producing heat at a higher value in order to make all of that more economically efficient. And how would we use better the resource we have and not coming into such waste? That was the question. And perhaps you have something to add on that topic, Ortwin, I'm not sure.
Yeah, thank you very much for repeating the question, because it's still hard from an online position to hear what people say in the audience. I hope I've understood it correctly. I think there are two kind of problems here that you address very correctly. The first one is that we have a difference between, let's say, resource efficiency and economic efficiency. So we can see that it's often more economical to just leave the waste heat not used. To use it, you need more material, you need more systems engineering, you need to see that customers get the heat, and very often, as again, it's not on the right time. You have more heat in the summer but you need it in the winter, so on. And that's why very often it's economically better not to use it. And now for sustainability and for the issue of being really productive with what you have, it's very good to have this cascading of energy. And there are, of course, good models to do that. But again, we need to have other economic incentives to make sure that that's really being done, because it's not always cost efficient. And the second point is that very often, if you optimize one area, like getting the most electricity production out of a combustion process, we may actually end up with a waste heat that it's not high enough to have any real good use for it. So sometimes it's better to reduce the efficiency of the electricity production. You get higher waste heat, which you can then use as in a dual kind of energy system for productive purposes. And again, that highlights the issue that you need to look at those impacts in parallel to say, okay, yes, we need electricity, we want to have it efficiently, but if it means that the waste heat cannot be used for anything, it may be better to reduce the amount of energy generation to have higher temperature in your waste heat, which then can be used productively. And if you add the two together, it's actually more efficient than just having more efficient electricity. So in that sense, I think it's very good to have good systems engineering, systemic thinking between the various users and between the various production possibilities, and also to rethink sometimes the economic viability and economic efficiency, because the prices do not say really the impact for the environment. Thank you.
Thanks a lot. So I take two words from your last remark. The first is systemic thinking, and the second one is again circularity. In fact, that's I hand over to our
response to the same question.
Okay.
Sorry.
Maybe you can go on the side.
So maybe not very technical explanation, but here's one term that I would like to propose: storytelling. The ancient way of engaging the audience and making sure that they know about it, they learn about it. Actually, only a few weeks ago, I finished this book on biology, about the history of biology, how from gregarious bacteria, the life on Earth actually, evolved. And one of the paragraphs was, one of the chapters was focusing about how in the early stages of human Homo sapiens, they were trying to gather these old people who cannot contribute to the society, and their only contribution was through passing the knowledge as well as the overall skills through explaining everything to the younger generation through storytelling. So I would suggest to you, and I think Hanna mentioned this as well, Ortwin mentioned this as well, like about the cultural aspects, about the importance of to engage people, the public. So you think this is a very important topic for people to be aware of? Just reach out to me. Let's write an article about it, or maybe, I don't know, film something about it. And we can talk to larger audiences where we can explain, convey the main message, the inspiration behind this term, because the terms are fancy, they're catchy, you can throw them around, but in majority of the times people do not understand the importance of it. So that's what I would like to suggest.
Thanks a lot. So now we have a lot of job to do within FlexRICAN. It's translating all our knowledge and all our new findings into stories for you. Okay.
Not for me, for the general public and the stakeholders.
For the stakeholders, that's fine. Okay, François, you had a remark.
I like something.
We are approaching the end, and therefore
yes, that's not important in France. So we will shift a bit of the visit. So we reach 5 minutes. I'm not sure. So just to go with the question of France, this is very interesting because, for example, just I take an example, the example of the relationship we can have with the district heating network of Grenoble. So they could be interested on 1 year, and the year after, well, there is a new data center that is installing in Grenoble. So we will do this project in priority. This is much more economically interesting. So this is our logics. I mean, there's not a philosophy in long terms. Research infrastructure has an advantage. We take time to make a new, but we are thinking the way we will have a stable way of working. And we must imagine a flexible way. We must imagine a way of changing our way of working. If we want to collaborate with this institution, we will not modify them from scratch. So, for example, for district heating in Grenoble, no, I told about this data center. This is their priority. But in the past, they say, we will not recover your heat because we have a priority with a chemical plant very near. They have done the project, but now the chemical plant stopped its activity. And then they're coming back and so on. So if we want really to have a strong collaboration for recovering the heat, we have to be flexible also. We have to be able to change our way to work from a year to another, to adapt. So, and this is a challenge, I mean, for research infrastructure. So here, perhaps less for high field magnets because it could be flexible. There is some limit, but we can shift easily, experiment during the year and so on. Easily, it's a dangerous word, but better than constant power in ESRF and so on. But this is, I mean, in the early phase of the research infrastructure, we have to think about the boundary conditions that are moving, and we will not change that very fast. So perhaps we can a bit adapt more in this direction. So just a background.
Yeah, long-term planning versus short-term economics. That's okay. I propose to close because we are in France, but we have a Swedish project coordinator. So
and time pressures.
No, I was not there. But so thanks a lot to the panelists for having highlighted or enlightened the day. Thank you, Ortwin, for your participation. And at least we see you and and from your participation from Germany.